So when you look at this first question, we're talking about intervals. If you remember, intervals always have to do with the x-axis. So I want to know the intervals. It's increasing, decreasing. Okay, so this is the point -5, comma, who cares? This is the point -2, comma, who cares? Because it's only the x value. 2, comma, who cares? 4, comma, who cares? And 5, comma, who cares? Okay? So let's focus on increasing. Increasing means go up. So it's going up from -5 to -2. And it's also going up from 4 to 5. Decreasing means going down. It's going down from -2 to 2. Notice how I'm highlighting it too. I should have highlighted the first one so that way I know what's left. And then constant means it's not changing. So it's not changing from 2 to 4. Just a little bit of review because we're dealing with polynomials. Okay, so let's look at this next one. This next one, it looks like all these points are shown in this graph. Let's make sure. Okay, right here. And then they told us g of x. So I have one graph that they're asking about f of x. And then I have another graph they're asking about g of x. So it says the y-intercepts are opposites. Okay, let me figure out the y-intercept. The y-intercept of this one is 0, 5. Remember, it's the last number. The y-intercept of that one is -5. So I'm going to circle A because, yes, they are opposites, which means they aren't the same. Okay? The functions have an x-intercept. So if I'm going to find the zeros, I need to set this thing equal to 0. I'm going to divide by -1, which leaves me x squared minus 6x plus 5. I factor it, two numbers that multiply to 5 and add to 6, -1, -5. So my zeros for g of x are 1 and 5. And for f of x, they're also 1 and 0. So they're exactly the same, which means it affects c and d. Okay. And obviously they do share because we just said they're exactly the same. F of x has a larger maximum. Okay, the maximum means the top. Well, this doesn't even have a maximum, but let's pretend it did. I know this one has a maximum because it's going down. When they're asking about the maximum, what they're going to ask for is the y value. So focus on the y value if we're talking about maximum. But if you look here, this one has a max and this one has a min. So automatically g of x has a larger maximum than f of x. So f of x has a smaller maximum. I guess you could say g. Technically, it's a minimum. So that's kind of a weird question. So I guess you can anticipate on the test that either they're both maxes or both mins. Okay? All right. Create an example of each of these. A quadratic means squared. A cubic means x cubed. A quartic means x to the 4th. And a quintic means x to the 5th. Make sure when you're looking at my multiple choice options that it's in standard form. And check to see if you can simplify. Okay, so that's a multiple choice where I'm going to ask for one of them and circle all the ones that are. Okay, they want to know about the behavior of this. All it gave me was a table, so I'm going to fake graph these points just to see what it is. -5, 3, -4, 0, -3, -1, -2, 0, -1, 3, whatever. I know I'm off, but I know what it's doing is it's a parabola going up. So the end behavior would be positive infinity. The shape is a parabola. It's a minimum. The intercepts are, so for the x-intercepts, it's -4 and -2, so be aware of that for the intercepts. But then for the y-intercept, if you look at the pattern 0 something, it's going to be a positive answer. So whatever that y-intercept is, which I did fakely. I also know that there's an axis of symmetry. And when there's an axis of symmetry, that shows that it's symmetrical. Okay, so they're just going to ask you a lot about the function. Okay. Let's go to the next one. Next thing I need to do is create a function. If I'm going to create a function, I know my answer needs to say f of x equals. I need to do the opposite. Well, if I do the opposite of 2i, it's x minus 2i. The opposite of x minus 2i is x plus 2i. The opposite of negative 4 is x plus 4. I'm going to do a box for the first two. X minus 2i, x plus 2i, x squared, plus 2ix minus 2ix, which makes it gone. Negative 2, oops, let me pause it. So when I look here, negative 2 times 2 is negative 4, but I times I is I squared. If you remember, I squared is negative 1, so a negative and a negative actually make that positive. Therefore, when I multiply these two, I get x squared plus 4. Then I multiply that by x plus 4, do another box, x cubed plus 4x squared plus 4x plus 16. Don't forget to put f of x. This is the calculator section, so you could graph this in your calculator, and if you graphed it, you should only have a 0 of negative 4. So it should look something like that, where the imaginary is there, or something like that when you graph it, where only it's touching at negative 4 and nowhere else, because the other two roots are imaginary. Okay, let's go to the second page. All right, factor the polynomials. I see that it's not in standard form, and I don't like that, so I'm going to write it in standard form just because I don't want to forget at the end. So what times what is 27? I mean, what times what times what? What times what times what is x? What times what times what is 64? Now that I know that, I just play the game, little big. Take this, bring it down exactly how it is. Square the first guy. Square the last guy. And take these two and put them together by multiplying. Since this is plus, this is minus plus. Since this is the calculator section, I can take the original question, set it equal to the answer, and it should say true. Do the next one. Since there's 4 of them, I can see it's factor by grouping. If I'm going to write it out, 2xxx, negative 25xx. I have the 2's and the 2x is the same. You can do this in your head, by the way. You don't have to show your work, but I'm just showing it. Since this is plus minus, and this is minus plus, I know I need to take out a negative, and then it makes them exactly the same. Here's the match. If it doesn't match exactly, then you made a mistake. X minus 5 is the match, and then 2x squared minus 1. I can't take the square root of 2, so I'm done. Take the problem, set it equal to the answer, and make sure you're good to go. Okay? All right, simplifying this one. I need to find the 4th row, which means there's going to be 5. I have it memorized. But if you don't, you can do 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and it gives you that. Since it's to the 4th power, there has to be 5. So I'm doing 3x and negative 1. So I'm going to write it up top, squared. I mean, oops, to the 4th. Just kidding. To the 3rd. Squared to the 1st. And I know that one's out, so I don't even want to write it. So 3x, 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 3x. Then negative 1, well that one's out because it's to the 0. Negative 1 to the 1st. Negative 1 squared. Negative 1 cubed. Negative 1 to the 4th. I have to make sure I distribute. 3 to the 4th is 81, x to the 4th. 3 cubed is 27, x cubed. 3 squared is 9x squared, and 3x. Cross it off, cross it off, cross it off, cross it off. Remember, I'm messy enough. So negative 1 to the 1st stays negative, turns positive. Stays negative, turns positive. Now I'm going to multiply vertically. Okay. When I do that, 1 times 81x to the 4th is 81x to the 4th. 4 times 27 is 108, but it's negative. 6 times 9 is 54. X squared, 4, 3, 2. Minus is what has to happen. 4 times 3 is 12, negative 12x, and then plus 1. Remember, to get the answer, or to make sure you're correct, take the problem and set it equal to the answer.